I am Dr. R.Sagayaraj from St.Joseph Arts and Science College, Autonomous, Cuddalore, Tamil Nadu, India. Today I am discuss about some problem in electricity magnetism, Unit 4, subject code 19PH305. So first problem, calculate the coefficient of self-induction of the coil 100 turns when a current of 2.5 ampere produce a magnetic flux of 0.5 microweber. That is a problem. So now we go to noted as given data from the problem. So like here the magnetic flux 0.5 10 power minus 6 Weber. So here microweber. So that's why we change it to 0.5 10 power minus 6 Weber. Number of turns of the coil. So likewise here I put it here, and now we need a total magnetic flux linked with the coil. So what it is? It is denoted as pi. So total flux, the multiple of magnetic flux and the number of turns, then we have 0.5 into 10 power minus 6,000. What is our question? So to find the coefficient of a self-induction of the coil. So what is the relation of coefficient, self-coefficient and flux? That is a relation. Ultimately aim to find the L, coefficient of self-induction. Now you find the total flux pi. We know total flux. Already we know current. It is I 2.5 ampere. So here we see that 2.5 ampere. The current I is equal to 2.5 ampere. Now substitute here flux pi is equal to, so like this, the current is 2.5 ampere here. Now change 0.5 2.5, it became a whole number. That's why we put it here 10 divided by 10 into 10 power minus 6,000. So 1 5s are 5 5s are 25. So again 2 5s are 10. So like here we see that 2 10 power minus 6, here 100. So here 10 power minus 6 into 10 power 2, as a result 10 power 4 Henry. So now you find out what it is, coefficient of self-inductions 2.4. Another problem, a coil has self-inductance of 0.05 Henry. So the unit of self-inductance Henry. Calculate the EMF of induced when the current in the coil changes at rate of, that is noted as rate of 120 ampere second. So given data, so self-inductance, so likewise here self-inductance L 0.5 Henry, and changes of rate di by dt, so 120 a s power minus 1 ampere second per second. What is the relation of rate and self-inductance EMF? So that is a relations. That is a formula. Simple one. Now we have what it is, E is equal to minus 0.5 because of coefficient of self-inductance is 0.05, and its rate is 120. I'll put it here. You find the likewise this 5 12 was 60 and including 0. Then we have, so now you find the minus 6. So here the negative sign is neglected. then we have E is equal to 6 volt. That is over the second problem. Now we have third problem. In a coil, an EMF of 6 volt is induced when the current in the coil change at the rate. So note it, rate di by dt. That is important thing. 100 ampere per second. Find the coefficient of self-inductance of the coil. Find the coefficients. So now you find the L. So EMF, that is a EMF, right? So that is a given in the problem. So now given data. So likewise EMF 6 volt, its rate is 100 A s power minus 1. Already I discussed the relation between potential and the rates. So help us, E is equal to minus L di by dt. What is our ultimate aim? To find the coefficient. So we modify the problem. L is equal to minus E divided by di by dt. So here negative sign not significance. That's why here neglecting negative sign. L is equal to E divided by di by dt. But you know EMF, that is a 6 volt. And the rate already you know what it is, 100. Just simple put it, then you find the 0.06 Henry. Because of the unit of self-inductance is Henry, that's why here put it Henry. Fourth problem. An EMF of 200 volt is applied to an inductance of 100. So likewise L, EMF E, that is E noted, is applied to an inductance of 10 Henry. It has